So the question asks, are the lines parallel, perpendicular, or neither? And we can say they are neither. But I want to show you how to do this mathematically as well, because I think it's good to have that practice. So for the blue points, we're going to do the change in y over the change in x. That means we're subtracting the y's, y1 and y2. So we have negative 4 minus 4 over the x1 and x2. So we'll start with x2, so 5 minus negative 7, right? So negative 4 minus 4 is negative 8, and 5 minus negative 7, that's going to change to plus plus, because we had two negatives next to each other. 5 plus 7 is 12. Well, 8 and 12 are both even, so I'm going to reduce it. Actually, they're divisible by 4, so I'm going to reduce it by dividing by 4. 8 divided by 4, 12 divided by 4. And that is the slope of the first line, and we can check that back on our graph. So I have a point here. Oh, it's not going to let me. Darn it. I can plot it though. So I'll plot it in here. I have another point. Oh, I didn't want it to go away because I need to see where that point is. Negative 4, 2. So I'll have to just remember that. Negative 4, comma 2. And now you can see that point. If I go from the first dot to the second dot, you can see the slope is down to right 3. So negative 2/3 is our slope on that line. Next, we will find the slope of the green line. So we're going to do the change in y over the change in x. And this will be our x1, y1, and our x2, y2. We're going to subtract the y's. So y2 is 2 minus y1 is negative 4 over x2 is 2 minus x1 is negative 7. That first, before I do that, I'm going to change these minuses to plus plus. 2 plus 4 is 6, and 2 plus 7 is 9, which are both divisible by 3. So we get 2/3. Ooh, tricky. So are these negative reciprocals? It's a good thing we graph these because we can see, like, yeah, 2/3 and 2/3 and one of them's negative. That looks kind of cool, right? But what we would really need to have is for the green line to be 3/2, because a negative reciprocal, 2/3 negative, to be a negative reciprocal would have to be 3/2. So they are not because it was not this. It was negative 2/3 and 2/3. Not negative reciprocals. At the bottom of your page, you have some theorems. You can highlight these however you'd like, but basically what this theorem is saying is that two non-vertical lines are parallel if and only if their slopes are equal. So they are parallel if their slopes are equal. Any two vertical lines are parallel. Oh, I see what they're saying. So if we have two vertical lines, vertical means straight up and down, then they are parallel. And the reason that they're saying that is because the slopes of those are infinity, or undefined. It's like dividing by 0. The slopes are undefined, but they are parallel. Slopes undefined. And on the other one, you can just see that they are parallel because they have the same slope. Slope of line P is equal to slope of line Q. Our other theorem, and if you didn't copy what I highlighted, no big deal, copy what you think is important. Our other theorem says that two non-vertical lines are perpendicular if and only if their product of their slopes is -1. So what they're saying is if I multiply the negative reciprocals, so let me go back to that one we used before, 2/3 times -3/2, that equals -6/6, which is -1. That's all that's saying. And then a vertical line and a horizontal line are also perpendicular, as we can see right here. So this is perpendicular. And we show that with this little T symbol. All right, nice job on your notes.